Hello, everyone. I wanted to make a quick video for you to help with a couple of the extra topics that we only got to do one problem of in class. And some of these can be a little tricky. So I just wanted you to have other options in case you were struggling with this. So the first one we're going to do is these parallel parking problems. We did one of these in class, right? We did this guy in class. And now I'm going to work through this number 2 with you. So again, these are parallel parking problems, right? I've got a forward trig function and a backwards trig function in the same problem. So we're going to start where we always do. We're going to start on the inside and work our way out. So inside we have 2 times this inverse cosine. So we're going to start with this inverse cosine. We're going to figure out how to evaluate this first, and then we'll deal with everything else in the problem. All right, so this cosine and the 2 times this thing are gonna stay there. And this is a backwards trig function, right? So that means we're starting with a ratio and it's going to take me to an angle with that ratio. So I'm going to get an angle out of this. And so really we have to figure out what that angle is. 6v, that is my cosine ratio of adjacent over hypotenuse, right? That's 6v or 6v over 1. Is that on the unit circle? No, that's not on the unit circle. I don't have any v's in my ordered pairs. So we draw a triangle, where we always do. Now, Alex doesn't tell you this. I want you to assume that your variables are positive. That's just going to make your life easier. They don't necessarily have to be positive, but your brain is going to process this much easier if you assume they're positive. So if v is positive, that means 6v is also positive, right? Because 6 times a positive number is another positive number. And so 6v is a positive ratio. If I'm taking the inverse cosine of a positive ratio, it's going to take me to quadrant 1. So I'm going to draw a triangle in quadrant 1 because a positive ratio will take me to quadrant 1. And when you have a ratio that does not live on the unit circle, you draw yourself a triangle. Now, the only things that I know about this triangle is that my adjacent over hypotenuse ratio is 6v over 1. So I'm going to fill in my adjacent side here as 6v and my hypotenuse as 1. Okay, and I don't know what the angle here is, but this inverse cosine of 6v, it's going to take me from this ratio back to this angle in my triangle, and this is going to spit out whatever that angle theta is. Now notice, I don't need to figure out what theta is itself. This problem is really asking me to find the cosine of 2 theta next. And so to find cosine of 2 theta, we're going to need this triangle, and we're going to need it to be completed. So I have to figure out what this opposite side is. To do that, we are going to use the Pythagorean theorem. I'm going to use this adjacent side squared plus, I'll switch colors here to keep track of it. I'll call that b squared equals c squared, right? And this b is this opposite side. That's what I'm solving for. Oh, sorry, I didn't plug in my c. C's 1. I didn't plug that one in. Sorry, y'all. There we go. That's better. And b is what I'm going to solve for. So to start getting b by itself, I need to move this over. So b squared is going to be 1 squared minus whatever 6v squared is. And then I'm going to take the square root of both sides. But how about before I do this, I want to try to make this look a little prettier, because right now that doesn't look very pretty. So let's simplify. 1 squared is just 1 minus 6v times 6v, that's 36v squared. That looks a little bit better. And now I can take the square root of both sides to get b by itself. And that means that b is going to be the square root of 1 minus 36v squared. Technically, there's a plus or minus here. Is this side positive or negative here in quadrant 1? Yep, it's positive, so it's going to be the positive square root of 1 minus 36v squared. Okay, so the Pythagorean theorem here is done, and I have a full triangle here. And now I'm going to come back and I'm going to use my triangle to figure out what the cosine of 2 times theta is. Now, I don't know what theta is, so I certainly don't know what 2 theta is. And I know that 2 theta is not going to be on the unit circle, so I'm going to have to use this triangle. And I've got twice an angle, or a double angle, inside a trig function. So we're going to go to our double angle identities. And I don't think I wrote these all on this version. So we did these in class. For the cosine of 2x, we have a couple of options here. We've got cosine squared of x minus sine squared of x. Or if you rewrite these using some Pythagorean identities, you can also write this as 1 minus 2 times the sine squared of x and 2 times the cosine squared of x minus 1. All three of these versions give you the same answer. It just kind of depends on what your brain likes and which one you'd like to do. So if I'm doing the cosine of 2 theta, we can really use any version of this that we would like. We used the top version in class, the cosine squared of x minus sine squared of x on the previous problem. So I'll pick one of these two other ones. How about I'll just do this guy. I'll do the bottom one, 2 cosine squared of x minus 1. Okay, so this is the one that I will use. And again, I just picked that one at random. There was nothing special about that. I just thought we'd try a different one than we did in class previously, just so you could see another one. Okay, so now we just have to plug everything in. So I'm going to do 2 times the cosine of theta squared minus 1. So now we have to figure out what's the cosine of theta. Well, I'm going to go to my triangle here, and cosine is adjacent over hypotenuse. So that is 6v over 1, or just 6v. And so now I can kind of work this through. I'm going to get 2 times 6v squared, or sorry, 6v times 6v, right? 6v all squared is 36v squared minus 1. 2 times 36v squared is going to give me 72v squareds minus 1. And we're done. We're out of all of our trig functions. We only have stuff with variables left. This is the correct answer to that problem. If you have chosen one of the other two versions, like the 1 minus 2 sine squared of theta, or the cosine squared of theta minus sine squared of theta, you would still get the same thing. It would just look a little bit different to get there. Your process might look a little bit different. And I just chose this one at random just to show you a different version. So I hope that helps with your parallel parking problems in Module 10. Let me know if you have any questions or concerns, and I will see you next time.